What's up, everyone? So my guest today is Yannik Suhre, and he is a student at Frankfurt School. And I think he has something to say. So hi, how are you?
Hi Jan, how you doing?
Not bad, thank you. So you figured something out about cloud computing, and that could be very valuable for Frankfurt students. So what is cloud computing? Why we need that? Can you say something about it?
Of course. So let me share my screen with you
Sure.
that you see what I see. And I want to start off and first of all tell you something about cloud computing. And cloud computing is defined as the practice of using a network of remote servers hosted on the internet to store, manage, and process data rather than on a local server or on a local personal computer. So,
Okay.
uh, first of all, this is a lot to process. And of course, you might think, wait, do we have that at Frankfurt School? Do we have something like a remote server, even where we can process or even store our data? And I found out, yes, we have. All
Really?
researchers or all master students at Frankfurt School have access to something which is called the Wharton University of Pennsylvania.
Wait, so you said
And
the master students. What about the bachelor?
so I haven't explicitly read bachelor students. They just set it currently for masters and researchers, as
Okay,
far as I know.
okay, fair enough.
So most of you already know Wharton, right? Because what you know of Wharton is WRDS, which stands for Wharton Research Data Services. This is, for instance, where you can query some stock market in real time and get it back to your script. And what I found, and I told a lot of people, but nobody knew, is the HPCC. And now you might be wondering, what does HPCC stands for?
Maybe high performance?
High performance cloud computing.
Right.
And this is really awesome. So now let's with that in our mind, let's get back to the definition of cloud computing. And these are the core things of cloud computing. It's using a network of remote servers to store, manage, and process data. So now let's get back to our high performance computer cluster, which is exactly this. It is a remote server with 32 nodes and 512 GB of RAM, which every one of you can query and access. It has for each member of this HPCC or even of Wharton itself, we have a 10 gigabyte storage there.
Okay.
And the beautiful thing is it's accessible from everywhere, from your local PC. So you can be in Haiti, you can be in Canada or Germany. You can access it from everywhere. Probably not from the airplane, to be honest, because you need an internet connection. But other than that, you're good.
Yeah. Can I
And
ask a question? So you write here 32 nodes. So do you know how many cores one node has?
so I don't know exactly,
Mm-hmm.
but since it's pretty fast, I assume a lot.
So you know how fast it is. So you have checked it out.
Yes, I have checked it out and I'll
Okay.
present you shortly.
Okay. Okay.
Um, and just let me finish here for a sec, because this is what it makes interesting to most of the Frankfurt School students is this node can read Python, this node can read R, Stata, SAS, or MATLAB. And with that in the back end or with that processing power, me as a math student, so master in applied data science, can use it, or even a master of finance who's rather using R or even Stata, we can just send our scripts there, it get computed, and it just returns whatever we want to have in return, which
Wow.
I think is
Okay.
is
So
pretty good, right?
so I hope it's also user friendly.
It is also user friendly. So
My God, I cannot wait until you show.
so let me show you a small demonstration of how we can connect to it and what we can do. So now you should see my git bash window.
Yeah.
And basically you can use every command line tool there is. So you can use git, you can use command line, PowerShell, whatever. And it's fairly simple now to connect. You only have to go for SSH and then your username. I choose Gazella, and then at wrds-cloud.wharton.upenn.edu. As soon as you enter this into your bash, you will be prompted for a password.
Right.
So let me quickly copy my password into it, so I can show you further around. So now we can see it printed a lot to our git bash. And if I scroll up and up, we can see here, welcome to Wharton Research Data Services.
Yeah. So just one sec question. So
Sure.
you already have an account, right? And if you're now at Frankfurt School as a master student, so probably you just like go to their website and then the domain fs.de is enough to get an account, or how does it work?
Every student of Frankfurt School got an email from WRDS to log on. So in the beginning of each semester, when everyone is quite new, I think it took like two or 3 weeks, and then I got an email, and with that email I could just easily make myself an account at Wharton. So it should be accessible for everyone at Frankfurt School.
Sure. Okay.
And now you see here, this basically says we are logged into the cloud and we are the head node. So for the following demonstration, I will use Python because this is my go-to language. I think it's also pretty amazing. So what we can do here, we can access a child node. So for instance, I go for IPython 3. And now I'm in an interactive Python environment. It almost looks like Jupyter. So now I can just do basic things like import numpy SMP. I can now print out a random number, int. So this is fairly simple.
Can you do me a favor? Can you just like print out for me the first 10 integers from 0 to 9 and the squares of them?
Okay, so you say what you want to do for I in range of 0 to 11.
10 is fine. From whatever, it doesn't matter. Just print.
And then next line, and we want to print I squared, right?
Right.
I to the power of 2, and sure, we can do this.
Thanks.
Sorry. No, let me. No. Sorry.
Excellent. Okay. So you know why I'm saying this? Because later on I will show you that on Colab there is a problem with that sort of. But go ahead, please.
All right. So this is one way of accessing this. But the bad thing about it is we can't save this notebook or the code we've written. So let's do something way more fun. So I've written a script. And let me show you my script, which I've written and which I will send to the cloud in a bit.
Yeah.
So I've written, so this is my storage, and this is my file. So give me a second. Let me share that one with you. So this is the code I've written so far.
Okay.
This is just a decorator function in order for me to track the time. And this is a beautiful conversion function, which I just had with you. So I thought just put it into a function and execute it, because
yes,
then we also have a beautiful picture afterwards.
sure.
So it will calculate the convergences, the convergence, and it will save the image as test.png, and it will print done man. And since this function is decorated, it will also print calling the function and then needed and the amount of time it needed to execute. So here on the bottom, I just call the function, and it will return the function call, and then in the end, how much time it took. So now let me go back to our Git bash and show me how easy it is to send something to the cloud or to the HPCC. So it's as easy as gsub init.sh. And I know now you might be wondering, wait, we just had a .py file and now it's .sh. Yes, we need a shell script. But this is so simple, and it's so well explained on the website, so that I just skip that step, because it's really fairly simple. And I'll later on let you the website there, so you can look it up yourself. It's fairly simple.
Yeah. If I may add, that is also quite a standard way to push for a job on in general on clusters. Obviously, there are different systems, but if you sort of learn that, then it will be also good for other architectures.
Yes, so that's pretty basic. So the only thing I have to do now is press my enter button, and we see your job init.sh has been submitted. And with that script, I submit my init script, my init.py script I just showed you. Now let me go back to my storage. So as of now, you don't see a test.png or any other things, right? Just some hidden files, and then init.py and init.sh. So let me refresh, and now we see two scripts. And the one thing, let me share that one with you, because this is fairly important. First of all, it printed done man, because this is what the function printed, and then it also printed how much time it needed. And to run this function took the server 12.18 seconds. Right. And now let me go back, because I've prepared something for you to see how beautiful this is. If we compare that one to my local PC, which almost took 28 to 30 seconds, and now with that result in mind, this took only 12 seconds. This is almost doubled as fast. This is amazing, and you can send R scripts, Python, and just imagine about scaling up. This is a fairly simple script, but now imagine using grid search or sophisticated machine learning models, which have to train for like 8 hours, and this would only make it 4.
Do you know what? Do you know what, Yannik? I'm just like thinking, because the task you pushed on the node is very trivial for a big cluster, and because you just calculate a picture like a fractal image of 1,400 times 1,400 pixels, like a couple of million pixels. So if you would scale this up to, let's say, 10,000 times 10,000, maybe because of the process how to submit this stuff, maybe you get like even better range than double as fast. So yes. I wouldn't be surprised.
Yes, of course, because you always have to bear in mind that my local PC would take forever to do this, like especially at 10,000, and the node for him is just a task, and
Right.
he would just do it anyway. Exactly. So so in the end, these are two things where you can look it up. The one is my GitHub account, where I wrote a very simple introduction of how to use HPCC,
Oh,
and the
wow.
second one
Nice.
is
Very
the
good.
official Wharton UPenn website, which can only say which is really good. Um, and it explains everything really well. And I also had contact with the support one day, and they're so nice, and they help you out if you have any further questions.
Okay. Nice. No, looks very good. Yeah, so that would be the end of your presentation.
Yes, this is the end of my presentation.
All right. Okay. Yeah. So I think there's like, actually, I don't have any questions, because I mean, that is so easy. So people just like have to visit your GitHub page, and then they just like see how to. And if this is maybe not complete because you focus on the main things, they can just like go to Wharton. And I think, yeah, to figure out if you have really tasks which would take like hours, and then see how much faster it is, that would be nice to check out. But there's no need that you or me are doing that, so that student at Frankfurt School can do him or herself alone. So I think that was very helpful. So Yannik, so thanks a lot so far.
You're
But
welcome.
you know, in my little podcast, I always want to be as funny as possible. And now let me show you. So you know Colab?
Yes, of course.
Yeah, can you maybe tell a little bit what Colab is?
So Google Colab is also a cloud computing option. And what Google tries to do is to democratize machine learning. So everyone from all around the world can access Google Colab.
Right.
And you can use their resources to train machine learning models. And the beautiful thing about it is that Google offers you to use a GPU, which is way faster than a CPU. Yeah, so much for the pros of Google Colab. The negative things of Google Colab is that you always have to be present, so you cannot shut down your PC. And next thing is you can just have the connection to a node for I think 12 hours.
Right.
So after, if your calculation isn't done in that time, you get separated or disconnected from your kernel, and then whoosh, all your calculation is done.
Yeah. Okay. So yeah, let me show you. So here I visited the page, and there's a welcome page here, and they also have like very basic introductions. And here's one link, this introduction to Colab, which I like to click on. And so now we should take care that we don't violate some rights. So let me switch to 1 minute. I think there was something nice going on. And let me just like share it with you.
Set up on your own machine. Additional code cells are executed using that same runtime, resulting in a rich interactive coding experience in which you can use any of the functionality that Python offers. For example, here we define a variable containing a range of 10 numbers. In the next cell, we loop through this range, printing the square of each number.
Do you remember? So this is
Yes, so this is exactly what I did.
Yeah, and now see what this video is spitting out.
For convenience, we use the Shift-Enter shortcut rather than the play button to exit.
You see the square numbers? I don't see them.
I don't see square numbers.
Yeah, so I think there was like a little bit, it was async a little bit what happened. There's one other thing which is nice. So you can have like interesting graphs and so on. So it's a nice thing. And another thing which caught my mind is the following here. Let me start it.
Paragraphs, lists, and even mathematical formulas.
and now see the mathematical formula. So they picked actually something which is not really defined. So yeah, so I find it funny. I see, Yannik, you're not smiling or laughing. So, but I wanted to share it with you.
Of
So,
course, this is really funny, and I think the only one who would actually come up with that
exactly.
would be you.
Exactly. So I think it's fine to be a little bit nerdy. And I think, to be honest, so are you a bit. So, and yeah, so thanks a lot. I think that will be maybe not this wannabe funny part in the end, but the video might be very interesting for a lot of my colleagues and a lot of students at Frankfurt School. So thanks a lot, and
you're welcome.
Really appreciate it.
Awesome. All right, Jan. Thank you so much for having me.
Sure. Bye.
Thank you.